On the 5th of October, from 10 o'clock to 16:30 to 4:30, in Eindhoven there will be organized the Optical Wireless Communication Conference, a hot topic these days in communication, to communicate wirelessly via light. Pieter Hermans at Jakajima, you organized this a similar event last year, but again this year in a somewhat larger setup, as being part of the Photonics Application Week. So that's really a hot topic these days.
Yes, yes, indeed. And the Photonics Application Week is a week where we invite organizations to organize conferences, workshops, whatever, on topics on the application area for photonics. So we will, next to this optical wireless communication conference, we will have vertical farming, smart farming, low latency. We have a conference on application integration of photonics, so chips. And also there are workshops in healthcare organized by a hospital in collaboration with a hardware manufacturer. And there is an event organized on Microcentrum about photonics in manufacturing.
So we have a lot of topics on photonics in general. This time it is about communications, and we see in communications quite a number of activities that relate to optical communication. One is communicating between satellites in space over large distances. We see the indoor Wi-Fi activities, and we see on-chip communication using light flashes instead of microcurrent. That's the complete scope of the conference, but we will kick it off by going for long-range communication. Will Crowcombe, you are on the scientific committee and will chair that first session on long-range communication, I believe with a number of quite interesting speakers.
Yeah, absolutely. Yeah. So my name is Will Crowcombe. I'm a system engineer at TNO in Delft. I'm basically the lead scientist here in Delft for our laser communication program that we have running. Our activities are really based on this long distance or ultra long distance. So I'm very much looking forward to the conference, witnessing and seeing some of the presentations on the other end of the spectrum, the short distance side of things. But we have a range of presenters and ultra long, let's say, application area. Our first speaker will be Zoran Zotnik from ESA, from the European Space Agency. He's going to take us through ESA's plans as far as laser communication in space is concerned. So I think that's quite a broad, ambitious roadmap. So I think it'll be good to see that. Every time I see it, it gets bigger and bigger. So then we really have
there in space. Light will beat radio communication.
Yeah, sure, and many different different application areas, from deep space communication to let's say communication satellites in the geo orbit, so feeding them with terabit class and beyond links. And then very hot topic is inter-satellite links. So people are building now communication satellites for constellations, mega constellations, and the plans in the future are to link those satellites together with laser communication terminals to really enable those very high data rates. So it's an exciting and exploding area, and you see the largest companies are involved, from SpaceX to Amazon. So,
and you also invited people from Eutelsat.
Yeah, so yeah, so we have also a presentation from Alexandre Lepere. Alexandre is the R&D manager at Eutelsat, and he's also the advanced payload manager. So he's going to show and talk to us about what projects they're working on and how optical communication can, hopefully is going to play a big role in their future satellites. And then finally, we have right down in the weeds of the technology, we have a presentation from VTech, Jan Mink, and talking about some of the quadrant detectors that they're working on, which should enable these applications in the future.
So we span the whole range from really the applications and the roadmaps of the large agencies all the way down to deep technology as it is being developed.
Yeah, that's the idea. That's the idea, and I think it would be good to show the guys working predominantly in the ultra short range field what's going on in the ultra long range, and vice versa.
But I do think that we can learn a lot from what is happening with these laser beams and how these laser beams are being steered also for the short range applications. And in fact, at the end of the program, we dive quite deep into the technology where we again come back with this combination. We'll cover that later. I'd like to move on to the chairman of the second session, that is Deng Xiong of Eindhoven University of Technology, addressing the indoor part. Hello, Deng.
Yes, I'm Xiong. I'm postdoctoral from Eindhoven University of Technology. I'm mainly involved in the Wi-Fi system, both European project Eindhoven. So I'm in charge of the section on indoor media range application and links to different technical approaches. First, we will invite Daniel Benck from Wiedemünde, Germany. He will introduce indoor media range applications for industry user perspective. For example, indoor positioning and the indoor navigation system. For this kind of applications, I can say that they will be benefit much from the optical wireless techniques.
Because in the industry of the future, you really need to have these well-protected optical beams to ensure that no radio interference can intervene with the industry operations. And that's exactly the business I think that Wiedemünde in Germany is in. So I'm looking forward to what Daniel can say is about the industry of the future. But then later on, I believe we also dive more into the details of how these systems are being built in your session.
Yes, that's true. I think then the second speaker, Amir from Signify, will demonstrate a commercial prototype for the practical Wi-Fi system. He will really highlight the experience to use the ITU standard for the first commercial Wi-Fi system for indoor broadband wireless access. So he will really show how this kind of Wi-Fi system can be built for practical use.
Mm-hmm.
Yeah.
And then we move on also towards the protocols of the communication, because it's not only the beam itself, it's also how to handle the data payload with multiple users, right?
Yes, so this third speaker, Joyce van Wageningen from Signify, will present a protocol to enhance the ITU standard recommendation for indoor inter-domain interference handling by using a separate Wi-Fi controller. This approach is also currently discussed in the new version of ITU standard. So we'll see what's happening here.
Yeah, so that's really what is happening in the industry and what we will see in products. And I think in the next presentation, Jona Bijsens of the Catholic University of Leuven looks into the same topic, but then much more from a scientific point of view to see what can be improved still.
Yes, he will further present a fine-grained interference control mechanism for Wi-Fi resource management. Mm-hmm. Because currently both industrial and academic, the computation and the inter-user interference are also very important topics in our community. So
that's interesting to see. After lunch at 1 o'clock, we have Professor Ton Konen of Eindhoven University of Technology. He was a world record holder for these indoor laser beam communications at, I think it was 112 gigabit per second. Now we see that also in free space, huge bandwidths are also used. What Ton does is, particularly with his system, to make the beam steerable over relatively wide angles. So typically between two satellites, I don't imagine that they're suddenly 45 degrees in a different direction, but in indoor those things can happen. And Ton is quite experienced in steerable laser beams, and by the way, he has a huge background in optical fibers, so he really knows quite well what is happening.
Well, actually, Jean-Paul, it can be a challenge sometimes. If you can imagine satellites in very different orbits going in opposite directions, then tracking over large ranges, almost hemispherical, is a real necessity. Yeah.
And how do you track that in satellites, mechanically or by photonics, or is that exactly the point of research?
Yeah, exactly. So we track them certainly in our systems, and what you see the state of the art at the moment is it's mechanical. So you have you break the problem down from a coarse tracking mechanisms into fine tracking. So you split the high frequency low range domain into low frequency large range, and you have a balance of mechanisms, and getting the balance between those is a tricky thing. Yeah.
So in the conference, it's really good to challenge the photonic guys to make things cheaper, as they promised, than just mechanical steering.
Well, I would love to see photonic integrated circuits enabling more. You know, I'm a mechanical engineer, so it actually pains me a little bit to say, but replacing mechanisms in the future, it would be great to see, you know, optical beam steering in a kind of steady state way. I think that's what the future is, and I think hopefully we can develop the technology to go in that direction.
And to really make that challenge a little bit bigger, we hope to invite you and your team to the Eindhoven region, where we developed the compact disc and the DVD player, where in fact we have steerable laser beams, all with mechanics. And these beams, if you rotate the disc 48x times, then you reach about a gigabit per second. And that has all been made for a couple of dollars. So
amazing.
Photonics really has a challenge there to beat that. But after Ton's presentation, we go on with how to connect the system in the ceiling. The lighting infrastructure has the advantage that it gives narrow cells, but then you also must have a huge infrastructure to connect all these cells via a backbone. And the idea is to do that via wavelength division multiplexing over POFs. Different colors go to different endpoints in the ceiling, and then immediately the same signal is converted to infrared electrically, but then sent over the air, and the same signal processing there is used end to end. And Karina Carrera will present this, mainly work from Eindhoven University of Technology. We move further on to further applications with a presentation of the impact of signal bandwidth and on-off keying in VLC system, but then particularly for intensive care applications. As we know that hospitals don't like RF too much, that is an area where, of course, also optical communication can be beneficial. And then the last paper, I believe, in that session is a paper on space frequency power allocation. That's not the space that you mean, but that is in a room, the different locations and the different frequencies and the different time slots you can play with dynamically. And that is a topic that Thiago Elias Cunha will present. And then I think we move on to to a further session. And then it's your call again, Will. The components and photonics for optical wireless communication.
Yeah, so I think we have a presentation, a joint presentation from one of my colleagues, Martijn Teresse at TNO, and Paul van Dijk from Linnartz International. They're going to basically present a project which is ongoing within the Photon Delta ecosystem. So a group of companies in the Photon Delta region are basically, I think, 8 in total, all working together to basically get their technologies, their individual technologies ready for space. So making sure it's robust to the environment and reliable. That's the key word.
So integrated photonics.
And integrate, so getting those integrated photonics devices ready for the space application area. Yeah. So and this could be a really great opportunity for, let's say, pulling technology from this ultra short range application area and pushing it into the space domain. I mean, one of the big things that you see at the moment in the space domain is it's becoming more and more commercial, certainly relatively for space. So there's a real drive to lower recurring costs so that these technologies are affordable on large scales. And I think PIC technology will enable that, getting rid of these expensive mechanisms, for example. So that project that that presentation those guys are going to give is going to be about that activity they're trying to do to get the technology ready.
It's already our organizer, Pieter Hermans, questioning. Now we are in the Photonics Application Week, and these guys are going to tell us that we want to use mechanics to steer it. Why are we doing this in Photonics Application Week? So I hope, Pieter, that you're happy with the program that we are making there.
Yeah, definitely so. Yes. Yeah.
Well, in fact, exactly at that moment, we also switched to from the very long range to the short range communication, because the guys at CEST in France demonstrated micro LEDs, and they reach 7.7 gigabits per second. But over very short ranges. So again, the photonics, the design of the LEDs, then in the same session where we dive into the details. Well, that fits with the other photonics applications as well as the other components that we see in the rest of the session.
Yep. So interested to see what's going on there. Absolutely.
Then there is a paper submitted from Oxford where Wayahat Ali, if I pronounce it correctly, together with Professor Faulkner and others and Steve Collins, are presenting a topic on a silicon photo multiplier receiver. Demonstrated in relatively short range communications, but what I've always found interesting is that the Li-Fi systems typically are noise limited because of the preamplifiers, whereas a lot of photonics is limited by the number of photons that you get in. And it's really a different regime, a different theory behind it, a different way of optimizing. And apparently they move the boundaries closer to what we know from optical fibers by really counting photons. Is that what you do in space as well? Count photons or on noise?
Well, absolutely. So the data rate is directly linked to the number of photons you can get, and depending on the communication technology, that ratio changes. But a really interesting area is, of course, in quantum communication. So distributing quantum keys and the ways of doing that. Essentially, some approaches require sending entangled photons from place to place. Where every single photon counts, literally every single photon counts, and they count on single photon level. So that's an area that I don't think we cover too much in any of the presentations here, but I think will be a hot topic also for the future.
And the last two presentations definitely are relevant for the indoor communications and are very much related to photonics. There are these laws of étendue, and they really beat us hard in designing indoor systems because we want to have a large capturing area to get in as many photons as possible. It's really relevant to get the bit rates up, but at the same time we don't know where the signal is coming from. We don't know the angle from where it arrives. So from large angles, we want to put it as in a funnel on a photodetector. And what I've always learned is the law of étendue is the same as a funnel does not exist in photonics.
Yeah. And I guess also the bigger your funnel, the more you capture light that you don't actually want to capture. So particularly in the domain that we work in, minimizing that, it is a tricky balance getting that ratio right as well.
Yeah. And what's in the two presentations, the two final presentations is happening, is that you can break the law of étendue, so you can make a funnel in photonics style by converting the wavelength, by having fast phosphors. And I've always been critical to have phosphors in the communication link, but apparently both in Oxford and at Eindhoven University of Technology, people believe that that is the way to go. Jamie Rivas at Eindhoven University of Technology works on this, and he calls his paper Optical Metastructures for étendue reduction, so to solve the problems that we just discussed. And Anna Rias from the University of Oxford will speak about green absorbing fluorescent fiber communications. So that's again trying to capture in a small IoT environment. So where we have these small nodes without any power, still trying to capture all the photons via a green fluorescent surface. And they believe that that's really gonna work. And I think that's a nice overview where we hope that we have an interesting link bridging the long space, very impressive things happening with terabits per second in free space, and the commercial activities and the indoor activities and the ultra short range activities as they happen in Eindhoven.
Well, indeed, I mean, I'm not a specialist in this area, so when I hear you talking about all those technologies and all those names, I'm sometimes what's happening, but I do think what we've done together, this is the first edition of this dedicated conference on optical wireless communication. I do think indeed we have a very good starting point with very interesting and relevant topics and presentations, both from the invited speakers as from the papers, the submitted papers. And it's an excellent start for a series of these conferences where we can expand and where all the different application areas applying wireless optical communication should be interested in.
We are proud to do this in the Netherlands with a lot of activities in the country itself, but also now attracting invited papers from France, from Belgium, from the Catholic University of Leuven, and also from Oxford and several other places as well.
Yeah.
That's all going to happen on the 5th of October between 10 and 4:30. It's mainly online.
Indeed, it's online. Yeah.
I'm looking forward to meeting all these people online with very interesting presentations.